And my question is that non-square matrices are not invertible. Why? To say that they are not inverse. Remember that if I'm multiplying A inverse to B and I'm getting what? An identity matrix. It means that B should be equal to a square matrix, means that the number of rows should be equal to the number of what? Columns. Simply that answers that question. Okay, so that is the end of the first lecture. Is it? No? Which one is this? Okay, so that answers it. Please, that is all about matrix operations and the other ones, the properties that we are going to look at. The properties are just straightforward matrix properties. To say that, suppose I have matrix A, B, C. Okay, if I have matrix A, B, C, please, I can't see the share, so I've solved that problem, okay? You can see the slides now, right?
Yes.
Yes, please.
So let's go through the matrix operation. Please note that suppose we have matrix A, B, C, and they are all regular matrices. And we have I as an identity matrix. And also we have 0 as a matrix with 0 values for all entries. Then we can say these addition properties will hold, which is straightforward. Means that matrix A plus matrix B into bracket plus matrix C should be equal to what? Matrix A plus B plus. This is just a straightforward. The rest are the same. If this rule exists, then we can say that that exists. The next one is multiplication. Again, for associative property, we are saying that if the same assumption holds, then A times BC is the same as AB into bracket times what? C. And I said earlier, anytime you multiply a given matrix to an identity matrix, the answer is what? The matrix itself. Or an identity matrix times any given matrix, you give it the matrix itself. Same goes to the rest. And I've also tackled this one already, that if you multiply any given matrix by the inverse of that matrix, it should give you an identity matrix. Let's make progress. Then equality is the same. I'll be using this caveat here in our foregoing discussion. Given that matrix A is n by n and matrix B is n by p, and a third matrix is denoted by x, we will solve the matrix equation A times x is equal to B for what? X. We'll be solving that. Also, I've indicated this already, where if you have an inverse of a matrix times any given matrix, it should give you what? An identity matrix, which is Ix here. And an identity matrix times any given matrix should give you what? The matrix. Therefore, X in this form is equal to the inverse of what? A times what? B. Good. How do we find the inverse of B? We are able to do that by using, we have several methods to solve or to find the inverse of a matrix. Please note that for the purpose of this class, we are using what we call the Gauss-Jordan approach, Gauss-Jordan method, to calculate the inverse of any given what? Matrix. There are other methods you can use, but for the purpose of our evaluation and for this class, I'm going to stick on Gauss-Jordan methods to discuss or to find the inverse of any given what? Matrix. So that suppose B is any matrix that satisfies A, B, it is only possible to get an identity matrix if A is the inverse of what? B, as I intimated earlier. If we multiply the left side of both sides by A inverse, we get A inverse, which is this. The result should give us what? B. B is equal to the inverse of what? A. And I said we can do that operation using the Gauss-Jordan method, which we'll discuss in the next what? Lecture. Great. Now, as I said, we can have problem as business managers or as entrepreneurs. And every day there are problems that confront our business. We want to find solution quantitatively to be able to solve the business what problem. So that takes me to what we call systems of linear what equations and matrices. People, so a linear equation can be written in this form. Okay, a linear equation can be written in this form. Means that at every given point in time, I'm sure some of you, you've seen 2x plus 2y plus something, or 3y plus 3a plus. That is written in the form of what? A linear what equation. Means that we can represent this whole thing on a what? A straight line. Then how do we define each of the information we have if we have any given systems of linear equation as this? AI, which is A1, A2, A3, all the way to AN, and B are referred to as parameters. Then X1 all the way to Xn are referred to the unknown what? Variables, because that is what we have to find solution for. But because we are in a business school, or most of us, we say that this is not a statistics class. In business modeling, we won't be naming them as I have intimated up here. In business modeling, we are calling X1, X2, X3, all the way to Xn as what? We term them as what? Decision what? Variables. So oftentimes I'll be asking, what is the decision variables? Or what are the decision variables? Then we are looking at X1, X2, X3. I know somewhere somebody will ask, why are we not writing X1, 2x plus 3y plus 4z? If you have so many decision variables, from z you have to go to a, then that will be too much of a burden to write. So instead of writing 2x, 3y, 4z, we are going to name them as what? X1, X2, X3, all the way to Xn respectively. Therefore, those X1, X2, X3 to X something, we call them what? Decision variables. That said, we also have B. B in this equation will therefore be referred to as what? The resource. As I said, business, they are confronted with what? Allocation of resources. There is scarcity of resources. How do they utilize these resources to make an appropriate what? Decision? And we are saying that there are two main decisions we are looking at. Either businesses are maximizing profit or they are what? Minimizing what? Cost. And they are going to use the resources they have to achieve those what? Purposes. And by achieving those purposes, they have decision variables they have to what? Also consider. Then each decision variable is also identified with what we call a coefficient. Okay, so as I said, A1 is no more a parameter, but A1, A2, A3 are referred to as what? The coefficient of the decision variable. Coefficient of what? Decision variable. If we are able to understand these processes, if we have any problem given, we should be able to identify number one, what are the decision variables? What are the coefficients of these decision variables? Number three, what are the resources given in this problem? Once we do that, we should be able to evaluate the problem. So when you are going to Accra Mall, which I know a lot of you go there, Some of you just go to view or do window shopping. Others will only go and buy Coke and roam around as if there is nothing to do in life. Okay. The others too, they have some amount of money which they are going to use to buy some things. Now, if you know the cost of each item, given the money that you have, how much do you have to allocate to each of the items that you are going to buy in order to make the most decision based on the money that you have been given to what use? Is it okay up to this stage, everyone?
Yes, sir. No, sir. Some of us just joined.
If you just joined, don't worry, as I'm talking to those who have joined all this while. Class starts at 8. You just join, it's not my problem. Those who have been talking to all this while, please do you understand?
Sir,
Yes,
we've been around, but we had a network problem. That's why we went off.
I'm saying that anytime you have an equation written as this guy here, there are information that you have to identify with. And in business modeling, we have to identify these items specifically within the equation that we have. We have what we call decision variables. Decision variables, like I said, you go to the mall, you want to buy Coke, you want to buy Fanta, you want to buy something else. Those are the things you have in mind to buy. But because you don't know how many to buy for each of them, we represent the unknown variables as what? Decision variables. Means that x1 here, x2, xi to xn are known as decision variable in business modeling. They are we won't say unknown variables. We will call them decision variables. Then each of the decision variable comes with some numbers. So the unit price of the Coke you know the unit price of the Coke. You know the unit price of what? Fanta. You know the unit price of what? Sugar. Those unit price each are called coefficient of the decision variable. Okay? So if it is profit and a business wants to make profit, the coefficient of the decision variable is the unit profit that has been identified to each of what? The items to be sold. Then based on what we have available, B, in this equation, is referred to as what? Resources. Because you have to use resources to allocate or share among the decision that you have to make. Resources can be money, it can be time, it can be labor, it can be raw materials. These are the resources that you have to use. So if I have any given equation in this form, I need to be able to identify three things, as I said: the decision variables, the coefficient of the decision variables, and the resources that are what? Available. Please, is that okay? Yes.
Yes, sir.
Okay, good. So your parent gave you 300 Ghana cedis to go and spend on some items. And let me say those items, you have rice and what? Soda drinks. You go to the mall and you are told that a unit price or a unit cost of the rice, a bag of rice is 20. And a pack of soda is also what? 15. This is simple. You are thinking about how many of rice should I buy, bags of rice should I buy, and how many packs of soda should I also what? Buy. This is the problem that you have. Given that you have a resource of what? 300. How do we write a mathematical expression being able to know how many number of rice to buy and how many of soda drinks to buy, given the available resources of 300 Ghana cedis to what? To spend. So let's read the question clearly again. A household has 300 cedis to spend on rice and soda drinks. a bag of rice costs 20 Ghana cedis, and a pack of soda also costs 15 cedis. If the household should spend all the 300 cedis, you are asked to write a mathematical expression relating to the number of rice and the number of soda drinks to buy. Ladies and gentlemen, if you have such problem like this, the first thing